Right, if you see the history of IP, TCP/IP, it's not too old. It just started in 1970, maybe 50 years old, not more than that. So somewhere around 50 plus, little bit. So, and earlier, it was only between few computers in military, and there is also an Indian involved in designing this TCP/IP. This guy is an Indian. All right. So about IP, there is a forum called RFC. About IP, we can see that in 791. About TCP protocol, we can see in 793. That's the RFC number. That's like a number to identify the document related to IP protocol. 791. Not so important. Just I'm giving you like an history because we are beginning from the beginning. So we also had some older versions like IP version 1, version 2, version 3, but they didn't get the popularity because there was some flaw in it, a lot of problem. So later they fixed this 4 IPv4 as a standard. IPv4 is what we are learning. Not only IPv4, we will be learning IPv6. So whenever we talk about networking, the very important thing that will come into our mind is OSI, Open System Interconnect. So today's class is about OSI in depth. Now this is what the OSI cake pyramid, you know, layers. That's why I put cake here. Cakes will have multiple layers. So we have physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. This need to be remembered in sequence, in order. Why? Because it's a standard. This is the preparation method done to the packets in order to be a qualified packet in the internet. Means if you want to send a packet over the internet, it has to be prepared in this sequence. First, always comes the application, from where you generate the traffic, from where you fix bugs. See, when you want to troubleshoot something, we use an application to troubleshoot. When you want to send data, receive data, we use applications. Even now, you're watching this screen and listening to me through an application that can interact with the network. So such applications that can interact with the network, which can send and receive data over the network, we call it as application layer. And then presentation, session, transport, network, data, physical. We are going to see one by one now. Why is that application layer on top? If it is that, if application layer is the first one, why the number 7 given? See, if you see on the receiving side, this is number 1. Someone is sending data, will be receiving the packet on the physical layer. Physical layer is responsible for physical connectivity. So the data comes inside via physical layer. when I say physical, it is not always the physical cable, it can be even Wi Fi. Most probably, you may be watching this video, listening to me, using a Wi Fi laptop, a wireless laptop or wireless cell phone that doesn't have wire. So, because it doesn't have wire, because we use Wi Fi, it doesn't mean that there is no physical layer. Physical layer is always there, even if you have Wi Fi. That small Wi Fi adapter, that small Wi Fi transceiver in your laptop or your cell phone, that is what physical layer. If you don't have the transceiver in your laptop, then physical layer is off. You will not get internet. So there is some component which is responsible for receiving and sending data over the internet. That is what physical layer is. That component. Now if you turn off the Wi-Fi, when you turn off the Wi-Fi in your laptop, you cut off the physical layer. Then you will not go online. So physical layer is always there even if it is a Wi-Fi router. So when someone sends data over the internet, it comes to your physical Wi-Fi adapter or physical NIC card. When you have a physical cable, you'll be connecting to a network interface card of your laptop. Your laptop has got network interface card, a small port where you connect your Ethernet wire. We call it as network interface card, NIC card. The the port is called as NIC card. The connector that you put inside the NIC card, we call it as RJ45, registered jack 45, RJ, registered jack 45. Let me quickly show you how it looks in the internet. If you have a port like this, we call it as NIC card. All right, just the port side. No, I don't want to focus on this green color motherboard. Only this one will appear for you behind your big computer or in a side of your laptop or behind your laptop. We call it as NIC card. NIC, network interface card. And the wire that we connect to the NIC card will be RJ45. Like this. This is what RJ45 jack. The RJ45 jack. And the Ethernet wire will be crimped inside. There will be a wire called as Ethernet wire because the Ethernet standard will run on it. Yeah, like this. This is what RJ45 connector. So we connect this with this. You see here they have put nice picture or both together. This end you will see in your laptop. This end is what the wire comes from the router to provide you internet. Now going back to our presentation. So we are going to focus on these layers one by one. What is a physical layer? Physical layer, layer 1, via which the current, yeah, the current is used to carry data. Basically, binary means 2 because you have 0 and 1. What is that 0? Off. Current is off. What is that 1? Current is on. So our electrical current as data is what physical layer send and receive. It's like same old school telegram. Telegraph on those days we used to have to send and receive data. Only those people who learned the telegraph operation can understand the language. It's basically like a signal with zeros and ones. They type from India, and someone who is in US can understand that signal zero and zero and one, on and off, on and off, on and off, and they form a meaning to it, and that's how the telegram works. Just on and off signal. Similarly, the physical layer in the network device send our data in an electrical form, in the form of electrical signal, so that the receiving device physical layer can understand what we sent and give it to the receiving device. So the physical layer takes care of this understanding the electrical message sent by the sender, and it's the same physical layer which is also generating this electrical signal so that a sender can receive it and understand it. So physical layer responsibility is to use the cable, if it is physical network or a Wi-Fi adapter, to send the message in an electrical format and receive the electrical format message and give a meaning and provide a meaning or uh, translate it into the message which is sent by the sender. And if you see, there are a lot of network devices. There is one device called hub. This hub will be like this. And this hub is called as a physical layer device. The hub is called as layer 1 device. See, for every layer there is a device. For physical layer, hub is a device. Why we should not use it? Because hub will always broadcast. Meaning the ports of the hub, they are all in a group, one group. So we call as broadcast domain. They are all in one broadcast domain. All the ports of the hub will be in one group, one broadcast domain. And they will be sending anything that is received to every port, always. The reason is hub will not learn who is connected where. See, if the hub can learn that Mr. A is connected to 1, Mr. B is connected to 2, C is connected to 3, and D is connected to 4, when a packet wants to go to B, if hub knows that B is connected to 2, then it need not to send to everyone, it will send only to 2, and you can avoid unnecessary traffic sending to 3 and 4. Not only you send unnecessarily, you also make collusion. When everyone talks at the same time, what will happen? Collusion. It goes to unintended person. So sending everything to everyone, not really good. So this hub, which is a physical layer device, why? Because for the physical layer there is no address. There is no address to identify a device in physical layer. There is no address to identify a device in a physical layer. So because the hub don't learn anything from the packet, it is considered to be a physical layer device because physical layer device only don't use any ID. You will understand this much better when I go to second layer. So in short, what I want to say is physical layer is responsible for physical connectivity, whether it is Wi-Fi or wire. It is sending, receiving signal in an electrical form. And the device that is considered to be a physical layer device is hub. Why? Because hub don't understand any addresses, anything that comes in a packet. Physical layer also don't use anything like address. So a hub is a physical device, physical layer device. Because hub don't learn MAC address, it will always broadcast. As a result, it will always cause collusion. So we say one collision domain and one broadcast domain in a hub because to control collision and to take a traffic to everyone, there is only one controller in it. There's only one controller. That's why we have layer 2 device. Anyway, before going to layer 2 device, let's talk about layer 2 itself. Layer 2, we call it as data link layer. What is this data link layer? The layer where the MAC addresses are used. In order to identify the packet, when a packet is arrived, it comes with MAC address. So that MAC address is used here to identify the packet. And to send the packet, it looks into the destination MAC address. So there is an address involved in identifying a packet and also in deciding to whom the packet belongs to. Every computer has MAC address. Every port on a server or a computer will have a dedicated MAC address. And when a traffic is generated, that MAC address will be used to identify from where the packet comes and to where the packet needs to go. So when we have a data in the layer 2, we call the data as frames. Fine. Now, switches are layer 2 device. Hub is a layer 1 device. Don't use it because it always floods. Switches are clever. They don't flood always. They don't flood. They will not. You see, switches learns the MAC address. You see the MAC table on the right top. Interface 1. See the MAC address AOAFBD as an example. Likewise, interface 2, interface 3, interface 4. So we got 4 devices connected to the switch. All 4 computers' MAC address is learned into the MAC table. So when a first packet comes from this device, the switches will now get a chance to learn the device MAC address from the source field. Source field. In the data link layer of the packet, there will be a source MAC address and destination MAC address. From the source field, the source MAC address will be learned. For example, this one, A0, and this is A1. Now, when this computer sends any traffic, in that there will be a source address with A0. So this learns the MAC address A0 against the port number 1, interface number 1. So switches learn MAC address because they know where is the server connected and where is the computers connected, where the DNS server is connected, where this web server is connected, because it knows where, who connected. Whenever this PC wants to communicate to web server, it will send the packet straight into this. Because the PC also knows the web server's MAC address. How? PC knows the web server's MAC address by using ARP, Address Resolution Protocol. Now, the PC wants to talk to web server, right? So, in the PC, user V provide the IP address of the web server 192.168.102. When we put the IP address, ARP will learn the MAC address of that IP address and give it to you. ARP is a protocol which can get you the MAC address of a device if you will provide the IP address. So here I am providing the IP address of the web server. Immediately the ARP protocol, Address Resolution Protocol, the ARP Resolution Protocol can easily learn the MAC address of the device to which you want to send the traffic. I want to send a web traffic to this address 192.168.1.2. What ARP will do is it will flood a packet asking who is 192.168.1.2. The flooding goes to DNS server. DNS server will remain quiet. Why? DNS server says I'm not 192.168.1.2. I'm 1.4. So I should not talk. This also will remain quiet. I'm not 1.2. This guy says, hey, it's me. It's me. So this web server will respond by providing the MAC address to this computer which sent the ARP request. Using that MAC address, the second packet will go straight to this one because this port is already binded with this MAC address. In short, what I want to say is switches will flood only if the destination is unknown. Initially, first time, the destination will be unknown. Once the destination is learned, they don't do flooding. They map the traffic to the exact port where the destination is. They know who is connected where because they maintain the MAC table. Switches maintain the MAC table. So far what we have seen, after physical layer, we got data link layer, where the data is called by a name called frames. Layer 2 uses MAC address to identify a traffic. MAC address will be mapped against the switch port or the switch interface. As we see here inside the table, the MAC address is mapped to the port. You see, INT1 is the first port, INT2 is the second port. And in order to learn the destination MAC address, a protocol called Address Resolution Protocol, ARP, is used. What will ARP do? ARP will resolve the IP address to the MAC address. How? By flooding the traffic, by flooding the request asking who is this IP. For example, if this computer B wants to talk to this DNS server's IP address, the computer will generate an ARP layer 2 broadcast packet asking who is 192.168.1.4. When this ARP request is sent to port number 3, the packet will be flooded to port number 1, 2, and 4 because it's a layer 2 broadcast. Now this broadcast packet goes to first device. First device will not respond. Second device will respond because second device says, I am 192.168.1.4. I am supposed to respond to the ARP. So ARP reply comes from the DNS server. The other server on the right, www server, which is called web server, it will remain silent because we are not sending, our PC is not sending ARP request to 1.2. It was sending to 1.4. Mostly I'll use these two numbers to differentiate. 1.1, 1.4. I don't want to repeatedly read this big number 192.168. You need to understand that. Next. The next layer we have is network layer. We have seen physical layer, we have seen data link layer. Now what we are seeing is network layer. After physical, data link. After data link, network. Now our data in this layer is called as packets. Our data in this layer is called as packets. Data in data link layer is called as what? Frames. Data in network layer is called as packets. Packets. Network layer is considered as what? Layer 3. In layer 3, we have equipments like a router. Router is a layer 3 device. If the firewall will do routing jargon, that is also a layer 3 device. There are some switches which can do routing also. What does the routing means? The router does routing. What does it mean? They forward a packet by looking into the IP address of the packet, not the MAC address. If any device that can make a decision where to send, via which interface to send, based on the layer 3 IP address, means not based on the MAC address, based on the IP address, because IP address works on network layer. So if any device will decide the interface, the exit interface, any device that will decide the exit interface, any device that will forward a traffic by looking into the layer 3 information, the IP information of the incoming packet, they're all called as layer 3 device. Example, router, firewall, switches. Not all switches. Mostly switches will decide only based on the MAC address. That's why they are called as layer 2 device. MAC address resides where? In data link layer. But there are some special switches. We call it as layer 3 switches, meaning they can understand the IP address. They can read the destination IP address of the incoming packet and take a decision accordingly. So such devices are layer 3 switches. That is both a layer 2 as well as layer 3 device. In another word, we call it as multi-layer switch. It's a switch actually, but with some limited layer 3 capability. See, it's 100% switch. 100% switch. Which one? This layer 3 switches or 100% switch. Additionally, they got some routing capability. Limited layer 3. It is not a 100% router, but it is also a small router in a switch. So when we say network layer, what do we mean? We mean a layer where IP address is involved, IP protocol works. Those devices that understands the IP address, those devices that runs the IP protocol and understand the device with an address called IP address, they are called as layer 3 devices. Example, router, firewall, switches. Not a normal switch, it's a layer 3 switch or multi-layer switch. Why do someone want to buy a layer 3 switch? When you buy a layer 3 switch, one device which will do both switching and routing. So it is cost saving. Even the space is saved. If you buy a separate layer 3 router and a switch, it's going to be two devices. It's going to be two devices. If you buy just one device which can do both, then it is going to be a cost saving for you and space saving for you. That single device itself will do both switching job and the routing job. But when I have only a when I have only a switch, for routing I need to buy another device. So this is one device, this is another two device. Two spaces consumed. But when I buy a layer 3 switch, this is both layer 2 and layer 3. Single box. So space less consumed in the rack. We keep all the device in a rack like a shelf in a rack. So space is less consumed Think about the electrical power that you need to provide. When you have two separate devices, then you need to have two separate cables, power cables. But here you got only one device which can do the job of both switch and a router. Single power source, single power cable, and cost wise also comparatively less. Again, it has got only limited layer 3 service. It is not 100% router. It's a 100% switch, but routing capability is seen a little. So those devices that takes decision based on the IP address of the packet are called as layer 3 device. And layer 3 protocol works in this place. IP is a layer 3 protocol, network layer protocol. So we saw devices like routers, firewalls, and multi-layer switch. There are also a few more devices which can do routing decisions. So anything that can do decision based on the IP address, forwarding decision based on the IP address, they're all called as layer 3 device. They're all called as network layer device. Then comes the transport layer. This is layer 4. Transport layer is responsible for transportation. Transporting traffic from one device to a remote device. The transportation can be a reliable transportation or a best effort transportation. There are types of transportations. The reliable transportation is what called as TCP. The best effort transportation is what? UDP. So what is transport layer? It's a layer 4 in OSI, which is responsible for transporting via a reliable or best effort. Transport layer is also responsible for providing a service number called port number. What is a port? In transport layer, port means service. See, someone is telnetting. And the other guy is sending in FTP traffic. How will your computer know? Your computer receives two type of request. From Bob, there's the FTP request comes, FTP, file transfer protocol. And from Tom, SSH traffic is coming. And this is you. How your computer knows that Bob is asking for FTP and Tom is asking for SSH? port number. When Tom sends the request, he will put port number 22 because 22 is a number that is universally identified as the SSH service. And Bob is sending port number 21. So when a packet is received by you with port number 21 in the transport layer of the packet, when your computer sees 21, it understands, okay, Bob is looking for FTP from me. When your computer sees 22, your computer understands Tom is looking for SSH from me. So in order to identify the services that we need to provide, port numbers are used. So some port numbers provide reliable communication, some provides our best effort. Both the example that we saw, SSH and the FTP, uses TCP port type. TCP. TCP is reliable. UDP is only best effort. What does TCP stands for? Transmission Control Protocol. Transmission Control Protocol. What does the UDP stands for? User Datagram Protocol. User Datagram Protocol. So we got TCP and we got UDP. TCP is reliable. UDP is only best effort. Meaning UDP is not bad. TCP is reliable. Though I am saying UDP is best effort, I decide not to say unreliable. I'm saying best effort. See, I say TCP is reliable, but UDP I'm not saying unreliable. Because UDP is also a very important method of transport. So I use a word best effort delivery. Why? See, sometimes you need UDP for communication. Sometimes you need TCP for communication. Wherever there is a need for fast communication, we will use UDP. For example, currently we are using UDP because it's fast communication. Whatever I speak, immediately it should come and reach you. There cannot be any break in the middle. So TCP is the best. Sorry, UDP is the best. If you use TCP, every now and then there will be a break. Because TCP want to know that we are really connected. Every now and then it will check whether I am connected to Suganya, Rajesh. Every now and then it will send packet. Just, checking whether we are connected. And only when it gets confirmation, it will proceed with the user traffic communication. So for audio and video traffics, TCP is not good because in the middle it will stop and then it will check the connectivity and then again it will proceed. Not good. Though it is providing reliability, it is not good for voice video traffic. The streaming traffics, UDP is the best. For other traffics where you want to have a guaranteed delivery, you can use TCP. FTP uses TCP. SSH uses TCP. Telnet uses TCP. www uses TCP. Session layer. What is a session layer? It's like old school switchboard operators. You might have heard about the switchboard operators, meaning in olden days, if you want to make a call to someone in London or in very far away country, need not to be very far, even inside India, in 1990s, when you want to talk to someone from Bangalore to Chennai or Chennai to Bangalore, you need to book a call. First, you need to call the BSNL. Hello, BSNL. This is the phone number I want to talk. And he will create a section for you. He will say, okay, sir, okay, madam, we will get back to you after setting a session for you. So, what BSNL does is he sets a session between you and your friend in Bangalore. And then BSNL guy will call, sir, your session will be at 4:30, you will get a call. You pick the call, we will be calling you at 4:30, you pick the call, then we will connect you to your friend. Okay, it's now 2 o'clock, you need to wait for another 2.5 hours for 4:30 to come. And then 4:30 you get a call, you pick the call, you answer. It's a BSNL guy, not your friend. And now the BSNL guy connects you to the Bangalore friend. So there's a time frame set. In that time frame, you are allowed to talk to the Bangalore friend. Not all the time, whenever you want, only when the session is created between you and Bangalore friend, you are able to talk. Likewise, between two devices, when they do conversation, when they when they want to send and receive traffic, they cannot send any time they want. A session is created, established. A session is established. A time frame is established. Within the time frame, the data is sent and received, which is maintaining the session. In case if there is need for more time, the session gets reconnected. And once the conversation is over, the session gets terminated. Right? So session gets terminated sometime because the response is very slow, so timed out, something like that. Sometimes the session may not get terminated. It depends on the application, which is not good. So we have to terminate the session as soon as the conversation over so that you can have more other conversations. We cannot keep blocking. So session layer takes care of that, creating, maintaining, reconnecting, terminating the session so that multiple services can use the network. If you don't terminate the session, for example, if you and me are keep on simply holding the phone, not talking, can anyone else call you now? No, because your phone is busy. You have to close the session so that someone else can talk to you. In olden days, I believe even today, government office does this. Banks will do it. They will just take the receiver and keep it next to the phone so that every time you try calling the bank will be always sounding busy, which means they do not want to serve. So they don't want to attend the call. They simply take the receiver and keep it next to the, the box. The phone is always engaged. See what a cheap behavior Indians had in past when you try booking a railway ticket, when you try calling bank. How cheap they were. They used to take the receiver and keep it. The bank people, how rude they were when they get paid because of you. Hmm? They made you to cry. They made you to stand in queue in banks. Now, good that technology has grown. ATM has come. Those people, those foolish people, now they are really feeling that they are full. Good. So that's about session layer. Creates, maintains, reconnects, terminates sessions so that multiple services can be used one after the other. Every service cannot be uh, using the network at the same time, so there's need for a session. Next, the presentation layer. The presentation layer, three main functions are: it takes the data that is coming via the network, entered into your device in an electrical signal, and then now it comes to the data link layer, network layer, presentation layer, transport layer, and then the session. And now it has entered into the presentation layer. So what the presentation layer does, it is going to convert that code into a human understandable, usable data. And give that data to the application layer, because application layer is the place where we check the data, we read the data. So you see, this picture nicely shows it was an electrical signal when it is received in the presentation layer from the transport layer. And the presentation layer takes it, from the session layer. From session layer, you received as an electrical signal. It started from the physical layer, data link layer, network layer, transport layer, session layer. From session layer, it has entered into the presentation layer. So it's going to take this electrical signal and present it as data. Actually, the sender is sending this man's picture. He's sending this picture to you. But in the wire, it didn't come as a picture. It came as a on and off signal, like a telegraph signal. So there is need for someone to decode like this, so that you will understand what the data is. Will you understand this type of data? No. But you will understand this data. Oh, this man I know. This man was there, right there, every time in the corner of the street, always smoking. That's why he died soon. Stop smoking. No? He will say, you should stop smoking, guy. But what to do? He's already passed away. Smoked too much. Anyway, you will know the data when someone present to you. That someone is what presentation layer. That's why it is called presentation layer. It presents. When a user sends, it will present from this format to this format. It is presenting to the network. When the network provides you, see, if you are a sender, you will be sending this photo. It will be presented to the network in this format, so the network will understand. Now, when you are receiving, it will come as this format. Now, it is presented to you like this. Both the job, both the job means taking from zeros and ones and giving you a data in a human readable format, as well as converting the human readable format into a machine readable format, zeros and ones. Both the jobs are carried out by this guy called presentation layer. Not only that, it also compresses the data, meaning zips, so that the file size can be reduced. And also it does the encryption. So presentation layer job is to present in a format that you will understand. And also vice versa, from the human understandable format to the machine understandable format when you send the data. When you receive, it is from the machine language to human language. Presentation layer does that. Now, at last, the application layer is used to see what has been given in the presentation layer. Now, if there is any issues to troubleshoot, you can see that also in application layer. Session layer, you cannot see anything. Whatever that is wrong with the session layer, those issues can be seen on this layer 7, because layer 7 is what the human understandable format. All right, so we got application layer where the application comes. So what we have learned today is the OSI layer cake, the 7-layer cake. You need to know this in order. I said, the layer 7 is application layer. Layer 6 is presentation layer. Layer 5 is session. Layer 4 is transport. Layer 2 is data. Sorry, layer 3 is network. Layer 2 is data. Layer 1 is presentation. You see, P, presentation, D, N, transport, T, session, S, P, presentation, A, application. So if you want to know this in order, if you have not memorized this in order, you can follow this acronym. All people seems to need data processing. All application, layer 7. People, presentation, layer 6. Seems, session layer. It's your wish. You can memorize like this, or you can keep this statement in your sentence in your mind, and you can now write the order of the OSI without shuffling it. And as we saw, physical layer is taking the traffic in and giving the traffic out in the form of current. Data link layer switches works in data link layer because they decide based on the MAC address. Network layer routers work in network layer because they decide based on the IP address. Even the firewalls, even some layer 3 switches. Transport layer is for the transportation. TCP or UDP is used. Port numbers are also decided based on the service. If you are doing SSH 23 is given. No, 22 is given. If you're doing telnet, 23 is given. Those numbers are reserved. Session layer is to set, maintain, reconnect, terminate the session so that multiple network traffics can use the network at various given session time. Presentation layer, as the word says, presentation layer, it is going to present it to the user in a user understandable language, and also it takes the user understandable language and present it to the network in a network understandable language. At last, the application layer is the place where we generate traffic, we read, write mails, and if there is any error also we can see from the application layer so that you can fix it. Right, that brings us to the end of the OSI reference model. Any question, please ask. Okay.